ZF6HP series torque converters differ from other models by the presence of pre-tightened friction clutches. This design feature can become an obstacle for many workshops that specialize in the repair of automatic transmissions. In our video, we will tell you about all the nuances of repairing 6HP series torque converters using a specific example. The first stage in the repair of this series TC is cutting its body. For this, the torque converter is mounted on a lathe using special equipment. After installing on the machine, the torque converter neck should be wrapped to reveal deep scratches, cavities or dents. Next step, the operator removes the weld seam with a cutoff or through cutter and separates the cover and the body. Torque converter cutting should be done strictly along the weld seam, avoiding excessive metal stripping directly from the body if possible. The type of cutter or carbide inserts for this type of work, as well as cutting conditions, are selected according to catalogs of metal cutting tools and reference books. For the final separation of the cover and body, we resort to light tapping with a hammer or a punch made of soft metals. After depressurization of the housing, the remaining transmission fluid will flow into the machine sump. Next, you can start disassembling and cleaning the parts. The body and internal parts are thoroughly washed. Inspection of thrust bearings, blades of wheels of TC is carried out. The sprag of the reactor wheel is checked. The service organization logo is marked on the body of the TC. Next, the body joints are cleaned. The halves of the body should be freely combined, no skewing and friction. The next step is to gain access to the friction plates. As you can see, this TC was previously repaired, as evidenced by the non-factory welded seam in the place where the support disc was attached to the cover. For this, the cover is mounted on the machine, where the turner cuts off the weld seam between the cover and the platter. Then you can start troubleshooting and replacing worn parts. Friction plates of the TC lockup fail most often. Before replacing the friction lining, it must be placed in a container with transmission fluid for at least 2 hours so that the material is well saturated. Pre-saturation of the friction pad is necessary for further testing of the locking mechanism, since the dry material differs in frictional properties, which will give an error when tested on the stand. We change the oil seals and rubber seals for new ones. If necessary, we replace the support bearings. Install a previously prepared friction plate. Assembling the locking mechanism. Check the preload value on a special stand. The pneumatic cylinder, through a special adapter, presses the spring support plate to the pump housing. Using a special adapter, we turn the friction plates. It is necessary to rotate the discs smoothly without jerking. The value of the transmitted torque by the pressed friction discs is recorded using a dynamometer. For different models of TC, the nominal torque value may differ. If indicators are within factory tolerances, weld the platter to the cover. Welding must be carried out directly on the measuring stand. without removing the clamp from the supporting plate. The stand has an adapter for supplying compressed air to the cavity of the TC cup. This will prevent the rubber products in the lid from overheating due to more intensive cooling. Also, in order to avoid overheating, welding must be done in small segments. After welding, the resultant frictional torque preload must be rechecked. Make sure it is within the normal range. Once the lockup unit is assembled and checked, you can start welding. The assembled TC is installed on the welding machine, where its body will be welded. Before carrying out welding works, the operator sets the size of the thermal gap between the two halves of the torque converter. For the unit to work correctly, it must be 0.5 to 0.6 mm. To achieve this value, on the stand it is necessary to set the gap between the upper and lower halves of the TC housing by 0.3 to 0.4 mm more than required in order to compensate the shrinkage of the weld after cooling. We start the welding process. At the initial stage, the machine symmetrically fixes the parts to be welded by installing 8 welded points. This prevents the occurrence of thermal deformations of parts during continuous welding of the body. At the end of welding, the operator checks the axle runout tolerances. Allowable value is up to 0.2 mm. The next step is to check the resultant thermal gap. The stand allows you to determine the size of the thermal gap in torque converters of various designs, both before and after repair, with an accuracy of 0.01 mm. Further, the TC moves to the leakage test stand, which allows you to quickly identify the places of possible leaks along welded joints or in other places of the body. For testing, air is injected into the housing under pressure, and then the torque converter is immersed in water. The presence of bubbles will indicate the location of possible leaks. It is advisable to keep the tested unit on the stand for several minutes, because possible violations of the integrity of the case may not appear immediately. After final testing, the repaired torque converter is ready for installation.